I recently hosted the first ISEC tournament and invited one of the participants, Pascalis, to explain how he built his project. In this video, you will learn how he set up his simulation of a robot with mecanum wheels. But first, let's have a look at his video submission.
Hello LycheeAI community, my name is Pascalis and this is my contribution to the community challenge. So I've had this robot for a while now and always wanted to simulate it, so this challenge was a perfect push to finally do it. The robot uses mecanum wheels, which are made up of individual rollers. These allow it to move not just forward and backward, but also side to side, diagonally, and even rotate on the spot. It's super agile, but therefore also pretty tricky to simulate accurately. In Isaac Sim, I created revolute joints for each roller, so they can spin freely. The main wheels are driven using angular drives. I also built a custom Python UI extension that allows me to control the robot inside Isaac Sim. And as you can see, the simulated robot behaves very closely to the real one. So yeah, that's my entry. Thanks LycheeAI for hosting this, it was a lot of fun. And if you're interested in a deeper dive, whether it's how I built a physical robot or set up the simulation, let me know in the comments. Thanks for watching, stay curious and see you next time.
Thanks Lychee for having me. My name is Pascalis. I'm currently employed at Accenture and also work there by day as an Omniverse developer. So yeah, that turned my hobby to my job, I guess. So I was very glad to join you for this community tournament.
Yeah, and I think it could be very insightful for people to see how someone who participated created the project. And I would like to have you present everything, how you did it, how you imported the robot and the scene and etc. But first of all, how did you come up with this idea for the mecanum wheel?
Yeah, sure. So I bought a robot a few years back, and I built the real one, and it's pretty cool with this mecanum wheels. It drives very agile. You can drive it in every direction, and I always wanted to simulate it. So, but I think I like just the motivation to do it, and I think your challenge was just the right push to finally, finally involve myself in Isaac and really simulate the robot I had laying around for so many years.
Nice, that's lovely to hear. Yeah, so maybe let's dive right in. Some questions on how you created it. So how did you start importing this robot? Where did you get it from, and how did you get it into Omniverse or USD?
Yeah, sure. So I found actually the models of the wheels at GrabCAD. But the thing that was problematic with the GrabCAD version was the design of the rollers. So they were not elliptical. I can even have a look here a bit deeper into the rollers. As you can see, they're like in perfect ellipse. And when you see the wheel or view it from the side, it's a bit hard for me to do right now, but it's actually like completely round. So it doesn't jiggle around when it drives. And so yeah, I just took like the visuals from the GrabCAD version and remodeled the rollers in Fusion 360, and then just matched it so that it looks correct.
Okay, cool. And I suppose you recreated the joints within Omniverse as well, right?
Yeah, so everything physics related I did in Omniverse. So for example, the joints, but also the colliders, rigid bodies, and also the mass of the wheels. All of that I did in Omniverse, yeah.
Cool. I think maybe diving into every aspect would be a bit too much, but could you maybe show the audience just like one example for one wheel and like do it kind of on the spot right now, if it's okay?
Yeah, sure. So basically what we have when we have mecanum wheels, we have two different ones, and the rollers are in a 45-degree angle. And we have an A version and then a mirrored B version. And just look at this, we can just look at this one here. And as you can see, it consists of multiple rollers, as I mentioned before. And for each individual roller, I introduced a revolute joint, as you can see here, so that it can move freely. So it can just rotate freely. All the rollers can rotate freely. But then the base of the actual wheel, where all where basically all rollers are attached to, also has a revolute joint, and this is the one that I drive. So in reality, every mecanum wheel has like its own DC engine that can drive it, so that you can drive it individually. And I think I will also show it to you later. But yeah, so we have one angular drive that drives like the whole wheel, and then the rollers are sub-assemblies or subcomponents of the whole bigger wheel. So I can show you how I import the files. So basically what I have is two step files. And one is, as I said, for the A-type or the left wheel, and the other one is for the right one. So they're just mirrored. And I import them. And what I disabled was this instancing. because I didn't need it for my purpose right now. And then I click OK, and it imports it. And this is actually pretty nice with Isaac, that you can import so many files, CAD files, out of the box. I will quickly just make them invisible, maybe. Can't find it. Oh, here, yeah. So I rescaled it also, obviously, but this is how it looks like. So this is a step import. It has no materials, just has the meshes, basically. And what I basically did was just click here, right click, and then add under the, I think it was, under physics, a rigid body. And also under the mesh, I added right click, add physics, a collider. And for the collider, I don't know if it's the right way to do it, but I used this, where is it? SDF mesh component. I think I'm on the right, not on the right property. Yeah, here it is. I used SDF mesh, and as you can see, it really approximates the actual mesh of the roller, which is very important for the physics simulation. You know, to be elliptical and to not have this jiggle when it moves over the flat surface. So, and the other thing that I still had to do was then to add joint, and I used the Revolute joint. And as you can see, it already has the correct alignment. If it's not the case, you can change the axis, for example, turn it around this one, but I didn't need it for that one. And with that, I was basically done. I just had to also select the you say it, like the body, like the base of the wheel, which it rotates around because of this one. Yeah. So and I had to redo it basically for every roller, right? And then was able to attach this to the body of the robot.
And just for what you probably did was also to import like a physics scene before in a ground plane that has colliders so it doesn't fall.
Yeah, exactly. Yeah. Exactly. So I used actually the Isaac warehouse because it looks kind of nice and it's free and already in the Nvidia Assets, as you can see. It's photorealistic. And I also have a plane which is turned invisible. And as you said, Lychee, I also introduced a collider to this plane so that the wheels don't clip through the warehouse.
Yeah. Yeah, cool. The warehouse looks really cool. It does require a lot of compute power. So I see you have a 5090. So probably for some people it may load for a long time, or it will be maybe difficult to have physics, like for those who don't have a powerful GPU. But there are smaller warehouses that you can use and also other assets. Could you quickly show again where you found these assets?
Yeah, sure. So it could be that the Nvidia Assets window that's here on my bottom screen is not directly loaded, but I think under Windows and Examples, or I think it was here, under Window and Browsers, you can also the Isaac Sim Assets, we haven't talked about them, they're also pretty cool. But there you can enable those windows, so the Nvidia Assets and materials, which I also used. So there's a huge material library, which I used to apply the actual looks to my robot. And as you can see here, so we have photorealistic materials. Yeah, and here under the Nvidia Assets window, for example, you have a lot of different assets, like from commercial and industrial equipment and residential assets. And yeah, they're all, I think, free to use, but I mostly like the Isaac warehouse, so that's what I used.
Yes. And this first tournament's challenge was to have a mobile vehicle robot, so which is able to drive. And you already mentioned you introduced an Revolute joint in the middle that had an angular drive. Mm-hmm. Can you maybe quickly show in the properties like the setting for it, and then maybe also transition to your extension that you have created?
Yeah, sure, of course. Good. We're back with the focus on the robot. And we'll just quickly show you. So we talked about the individual rollers, right? Which all have Revolute joints, but they can move freely, so they don't have a drive. And this is what I changed for the actual base of the wheel, which also has a Revolute joint, but is connected to the body of the robot, and this plate here in the middle. And here in the Revolute joint, if we go into the properties, you can see that I also have an angular drive. And currently the target velocity is 0, and the damping value is set to 100. This is actually relevant to have it higher than 0 if you drive target velocity. And I think if you use target position, you will need to have the stiffness over 0. And I also created a small extension. So it's, even show it to you. So if I have here the extension window, I named it just by myself. So after myself. So it's here. It's a mecanum robot UI controller extension. And you can see if I toggle this one, it will turn the extension on and off. And what I have here is just some driving scenarios that will change the revolute joint angular drive properties of each wheel to the expected target velocity. Because in a mecanum wheel, it depends how you drive the angular wheels. You can achieve different driving or locomotion behaviors. And I can just show it by starting the simulation and maybe just drive it forward. As you can see, all wheels spin forward, and I can also drive it backward, and can also move it to the left. Sorry, it's getting a bit, the performance is getting a bit laggy. But I think you get the concept. And even, that's also cool. It can also spin on the spot, left and right. It's also actually very fun to play with a real robot, but it's also nice to to look at the simulated one. Yeah, I can also just stop the wheels and it stops. There's still some jiggle, and I think it's due to some performance optimization that I can do, to make it more realistic. But I haven't had so much time to look into that.
Yeah, there are a lot of parameters that can play a role. Like for example, I believe the physics frequency. So if you go to create on the top,
let me just quickly, because it's getting a bit glitchy. Yeah.
Here. And then under physics, physics scene here. Exactly, yeah, it's on something here. And as you can see, it says in the properties, time steps per second here, yeah.
Yeah.
And if you up that to something like 120 or just double it, or maybe even 500, something like that, it might resolve some issues as it's computing faster, basically. And
it looks better, right? Or is it just me? Right. Well, there's still some.
And if you stop it, maybe.
Yeah.
Oh, nice.
It's calmer now. Yeah.
Nice.
Thanks for the tip.
Yeah,
good to know.
It's but there are a lot of different settings. It can be friction. It can be colliders. Sometimes are too good or too bad or whatever. So they're colliding with each other. So self collision and stuff like that. And it's a lot about experimenting. Honestly, trial and error. But
yeah, a lot.
I just wanted
one thing that did change for me. Sorry that I interrupted you. Was this mass component? Because the mass gets auto calculated, and it gave the rollers and the base of the wheel basically the same mass, I think, or close to the same mass. But if you play around with this value, at least for me in my case, it made a huge difference in reality and in simulation.
I just wanted to touch on the extension part again. I think a lot of people don't realize that or don't know, but basically everything inside i6 Sim is an extension itself. Even the viewport that we see is an extension and the stage. And what you have done is to also just create an extension via Python code. I believe you used the extension manager, I think it's called, to create
this is a Git app template on Git. And you can just basically just copy the repo, and it walks you through it on how to create either an extension or even a customized Omniverse application. Because I think not only the i6 Sim is configurable, but also the different Omniverse applications are basically just a bunch of different extensions, right? So Composer, Explorer, i6 Sim, i6 Lab, they basically sometimes use the same components.
Yeah, they're basically all the same. They just load different extensions in a way. So yeah, that's basically Omniverse is full out of extensions, and everything is built on kit and USD. So technically, you can create your own software, basically, or platform where you can load different things. So that's really cool about Omniverse. And as they have open sourced everything, you can literally do everything that you want. So yeah, I thought it was worth mentioning it. And I just wanted to add that while you have created an extension to use it, it is also possible to use ROS, for example, for people, and use like Isaac ROS. Or you can even have a standalone Python script that you just launch, and you don't have any UI interface, but you would probably, what you could do is to connect it to your keyboard and listen to events from your keyboard to change the Angular drive states. So instead of you clicking like the buttons, you could listen to keyboard commands, for example. And what I wanted to say with that is like not everyone has to create an extension. You have a lot of different ways to control the robot like that. It's just up to your liking.
Yeah, that's correct. I use the UI version, but I also have another one, as you said. It's only purely Python based. But I thought for the tournament it would be also nice to actually see where I'm clicking. And yeah, I can maybe switch to the code real quick. So when you create the custom extension, you basically get this folder, and in there's already a Python script that you can edit, and also some other stuff that you can also change and yeah, basically improve your extension to do all sort of things. And this is just my simple Python-based one, where, for example, I define where the joins are in the stage, and have also the definition of the UI for the user to see. And here are the different movement scenarios that I just showed, so moving forward, backward. And what it basically does is just sets the velocity value of the Angular drive to the one defined in the UI, and also some other debugging stuff. But I think I don't have to go into so much detail for that.
Yeah, but cool. Maybe you could upload it on GitHub if people are interested. Maybe if you
sure, yeah.
So some people have asked
same
for the code.
Yeah, sure. And same for the wheels. So I don't have the rights to the auto shells, but to the rollers. So I can upload at least the rollers and the Python code. And everyone would like to recreate it, could do it then by himself.
Cool, awesome. Do you have any, maybe to wrap up the video, do you have any maybe last things you want to mention? Maybe some difficulties that you face that you would do different next time while creating this?
Yeah, well, I'm still not an expert on USD and what are the best practices for that. So, for example, the wheels, which are in a step file, can also be imported as with this prototype component, so that basically every roller would be just referencing a prototype. And maybe it could also be done directly, with directly with the correct colliders or even the joints, so that you don't have to apply it all manually to every roller, as I did. And maybe also experiment with a URDF file, the Universal Robot Definition file. Did I have it correct? Is it called like this? But
yeah,
basically,
description file.
Yeah. Yeah. Basically that. I'm not so familiar with USD yet, but we'll get there I think at some point.
USD is meant for like the universal scene description, basically meaning they want to have one tool to connect everything. I guess that was Pixar's intention with USD in the beginning. And I also see FBX files, and I think FBX files here have material properties and everything inside them too. So yeah, so you can also import materials along your step files, for example. Cool. Yeah, so I guess if you don't have anything more to add, I guess we will wrap up the video.
Sure. No, nothing else to add. It was just a pleasure competing in the tournament. I learned a lot, and looking forward to the next challenges.
I hope to see you in the next tournament as well. And thank you so much for helping everyone on how to create your own robot and make it work.
Thanks for having me, Lychee.